Hello, this is Mr. Collier, and today we're doing proofs by counterexample. So counterexample can be used to show that a statement is false, and you just need to find one case where it's false, and then the statement is false, right? So let's take a look at A. If n is a natural, or if n is an integer, and n squared is divisible by 4, then n is divisible by 4. So we're just going to find an example where that is not true. And if you think about it, you can just run through the numbers till you find one, right? So 2 squared is divisible by 4. And I think we found one as easy as that. 2 squared equals 4, which is divisible by 4. But 2 is not divisible by 4. Therefore, the statement is false. Okay, let's look at the next one. N squared plus 1 is a prime number. Well, if you try 1 squared plus 1 is 2, that's prime. 2 squared plus 1 is 5 is prime, so just keep going until you find one. 3 squared, there you go, 3 squared. So 3 squared plus 1 equals 10, which is not prime. Therefore, the statement is false. Okay, in part C, if an integer is a multiple of 10 and 12, then it is a multiple of 120. Well, you just can maybe find a common multiple between 10 and 12. I think 60 is a common multiple of 10 and 12. So 60 is a multiple of 10 and 12, but not 120. Therefore, the statement is false. Okay, let's look at some other examples. This one, consider the set P of numbers in this form. Show that not all elements are prime. So natural numbers start with 0. You plug 0 in, you get 41. 41 is prime. If you plug in 2, you also get a prime number. You can go through a lot of numbers on your calculator and try to figure out one that's not prime. This gets a little bit difficult because the numbers get pretty big. So you pick a smart choice for n, and it's pretty easy to show. So a smart choice in this case is to pick n equals 41. Then you can write this number as 41 squared plus 41n plus 41. That equals 41 times 41 plus n plus 1, right? Therefore, not prime. Okay, so therefore the statement is false. Okay, our last example, show that the following statement is not always true. There are no positive integer solutions to this one. You just got to find a integer solution to it, and then the statement is false, right? So you can play around with a couple of numbers. They have to add up to 10, so we're looking for small numbers. 1 squared plus 1 squared doesn't work. If you think about it a bit, 3 squared plus 1 squared equals 10. Therefore, the statement is false.